Far side moon, a landing site to access both H2O rich PSRs in the inner South Pole Aitken Basin and a candidate site for Artemis base camp. So we've got everything here.
Hello everybody, my name is Erin. I am a senior undergraduate geosciences student at Hamilton College, and today I'll be presenting on my summer research with Dr. Pascal Lee at the SETI Institute. Next slide, please. So the primary goal for our research was to search the South Pole for candidate base sites for a future Artemis base camp. Our criteria here are listed on the left. We started out with a solar illumination of greater than or equal to 65% and an Earth visibility greater than or equal to 50%. Those two constraints resulted in 65 sites for further analysis, and those are plotted in red on the map to the right there. And at each of these sites, we analyzed the terrain to make sure that, one, we had a large enough area of flat land for a habitat area to be established upon, and two, we also had another area of flat land some distance away upon which we could establish a pad for rocket landings and launchings. We also wanted to make sure that there were trafficable slopes between the habitat area and the pad area. And lastly, we were concerned with the science access at each site, particularly as it would provide access to permanently shadowed regions and the South Pole Aitken Basin. So taking a look at this map on the right here, we have Mount Kocher, which is a positive relief feature on the lunar far side outlined in black, and that will be the focus of my talk today. Next slide, please. So taking a look at this map on the left, this is a slope map of Mount Kocher. The green pixels indicate slopes of less than or equal to 5 degrees, and the red pixels indicate slopes of less than or equal to 20 degrees. The blue polygons outlined in black are permanently shadowed regions, and the big red dot there is MK1. Now, MK1 is a site from our Artemis Base Camp study that fulfilled all of our Artemis Base Camp criteria. It has a solar illumination of 77% and Earth visibility of 60%. If you take a look at the map on the right, this is a close-up of MK1 on the slope map. The high illumination point is where the star is located, and the blue pixels indicate everywhere within a 2.5 kilometer radius of the high illumination point that has a slope of less than or equal to 5 degrees. So taking a look at this map, you can see there are multiple options for a habitat area of 1 square kilometer, and we also have multiple options for a pad area. Next slide, please. Now, one of the great things about MK1 is that it has access to an interesting PSR. So if you take a look at the map on the left, you'll notice that there are 3 permanently shadowed regions on top of Mount Kocher. One of these permanently shadowed regions was listed by Lemelin as having water ice stability. So this center map shows the least cost path generated in ArcMap between our MK1 site and this PSR that shows water ice stability. You'll notice that path is 8.1 kilometers in length and that it traverses over slopes of less than 5 and less than 10 degrees, denoted by the green and yellow pixels respectively. Additionally, most of this path, as you can see from the map on the far right, is illuminated at least 40% of the time. Next slide, please. Now, one of the things that makes MK1, or last slide, please, or previous. One of the things that makes the MK1 site in the Mount Kocher region so interesting in general is the fact that it provides proximity to South Pole Aitken Basin. You'll notice from the map on the left here that the Mount Kocher straddles the heterogeneous annulus and the magnesium-rich pyroxene annulus of SPA. And what that means is that we might have direct access to SPA basin mafics on top of the mountain itself. And an extended mission going down the mountain would otherwise provide abundant SPA basin mafics for us to study. Next slide, please. So a CLPS mission to MK1 would have the following objectives. The first would be to characterize water and other volatiles in, around, and outside the PSRs. The second would be to characterize the geologic diversity, mineralogy, and geochemistry of SPA materials. And the third would be to assess the site's potential for a future Artemis base camp. We would need a rover capable of traversing at least 10 kilometers, but it would not need to survive the lunar night, and a payload equipped with neutron, near-IR, thermal IR spectrometers, and a visible imager would be best to meet our science objectives. Next slide, please.
1 minute, Erin, 1 minute.
Thank you. An extended mission for MK1 would involve driving down the mountain Driving down the mountain would allow us to sample more South Pole Aitken Basin materials, as well as do more reconnaissance for Artemis Base Camp traverse routes. This traverse would be over 40 kilometers, however, it would be downhill. In conclusion, Mount Kocher and particularly the MK1 site is an exciting place for a future CLPS mission. We have access to PSRs, we have access to South Pole Aitken Basin, and a candidate Artemis Base Camp site. Additionally, the northern facing side of Mount Kocher may be an interesting place to put a far-side radio telescope, although we'd have to look more into Earth radio frequency diffraction at this site. Thank you.
Thank you, Erin.